Very good morning to all the senior pros out there. My name still remains Bamariga, Kampala Islamic. In our today's discussion of mathematics, we'll still continue with items. And we are going to be doing 2 items in at least an hour. The items are going to come from what Kamsa said as item 2, that is Kamsa Mok. And next one will come from Wakata, still under the same element, that is item 2. When you look at in the first item we are going to look at now, will come from Kamsa, and I hope the question was posted there, but can still read it for some summary. So in the first item we are saying, Gozi is an innovative young farmer in Buero district who grows sweet potato, sweet pepper, is greenhouse. He uses two systems, that is the solar system and the biogas system. Is greenhouse, but he realizes that the sum of the maintaining cost of the solar system and twice the cost of the biogas is shilling 35,000, and also the difference between the 3 times the solar system and the 2 times the biogas cost is shilling 5,000. He finds it difficult to determine the daily individual maintaining cost of each system. The papers he produced are of 2 categories, paper X and paper Y, whereby he wants to know the quantities in every category he can produce to maximize the profit. He realizes that he can produce at least 20 papers for X. The numbers of quantities for paper X should also not be less than twice quantity paper Y. Given that the cost for paper X and paper Y is shilling 200 and shilling 300 respectively, he wants to ensure that the total cost does not exceed 4,000. He needs to know the quantity of paper X and Y he can produce to maximize the profit, given that the unit profit realized from the paper X and paper Y are shilling 500 and 600 respectively. So when you look at still in the part of the task, you realize that the task is talking about 2 things. Like I have been telling you last time, that mostly these items comes from specifically the application of the simultaneous equation and programming. And that is what we are going to be looking at the moment. So we can continue by seeing the part of the task. In part 1, they are saying help Mr. Kizori to determine the daily cost of maintaining one solar system and one biogas system. And then part 2, they are saying present Mr. Kizori's produces as inequalities and the equations. And then part 3, help him to determine the possible quantities of paper X and paper Y that it should produce to maximize the profit. I will start by answering part 1, where in part 1, you look at that in part 1, they are talking about the biogas system and the green and the solar system. This is the simultaneous equation. I'm going to look at it in the form of a simultaneous equation. That is by our part 1. I will say let A be let A be the solar system and B be biogas system. So I am going to look at the two. Said that if our A is the solar system and when my B is the biogas, I am going to look at the total amount that can be given from that. This amount, then so we look biogas. Twice the cost of the biogas. They are trying to mean that if I have one solar system and two biogas, because the word twice means two, I am dealing with the two here. Then they're saying their sum should give us 35,000. And then the next part they are saying also the difference between the 3 times the solar system. Our air is the 3 times, meaning we have here 3 solar system and 2 times the biogas. Still, this one here becomes 2. They're telling us that the difference between those is the 5,000. So I am going to start by answering the situation 1, where they are talking about the sum. So you know that whenever they have given us something from the sum means an addition, meaning that if I go and add the one of the solar system and the 2 of the biogas, we should get 35,000. So we are going to look at this one here as the A, because if I multiply the 1 times the A, which is the unknown, becomes the A. Then I also look at the 2 of a B, that is the 2B, meaning that this one here means the solar system and twice the biogas. Their sum give us 35,000. That is for the first statement. For the second statement, they are talking about the difference. And you know what the difference is. Whenever we talk about the difference, it is a subtraction, meaning that if I look at the 3 times the solar system minus the 2 times the biogas system, we should be able to get 5,000. So we are going to have the 3, that is the 3A. And then we look at the 2 times their difference of 2B. We will have the answer to be given as the 5,000. So from these 2 statements, you realize that also we'll have 2 equations, and all these 2 equations are given in the form of the simultaneous equation, meaning that for us to come up with the price of or with the unit of each biogas and the unit of the solar system, we have to solve this equation simultaneously to come up with the value of A and the value of B. So we are going to solve the equation 1 and 2 simultaneously. Simultaneously means that the nature of what we are going to solve should only be having uh, that degree 1. When I talk of a degree means the power of the unknowns, which is given in an equation. So if I look at my equation 1, then I try to compare with equation 2, you realize that still I can use any method of my choice. Like last time I gave a summary of the methods that can be used in solving equation. To remind ourselves in 1 minute, we said that simultaneous equation can be solved using elimination. That is our first part, elimination method. Still at the same time, I can solve it using the substitution method. Or another person can also use the matrix method. Then someone can also use a graphical method. Supposed to use. Now, for me, at this point, I am going to use the elimination method, whereby under elimination, we go ahead by eliminating one constant so that we can come up with the value of the remaining constant. Like if I look at in equation 1 and then I look at in equation 2, you realize that by comparison, I look at the 2b being a positive on equation 1, and then I look at the 2b being a negative on equation 2, meaning that what I should come up with in my mind is that if I look at a number, a certain number, let us say we are having a number -1. This -1, if I go by integer, then I add a 1. You realize that all the answers always becomes a 0. The same thing applies if I have a 2 positive here plus a -2. Also, you realize that our answer still remains a 0. It is the same thing I am going to do here. I am going to say that if I have the equation 1, which is a positive 2b, then I have in equation 2, which is a -2b. What you realize here is that these two being of the opposite side or of the opposite sign, you realize that they will have to disappear. So what we are going to do here is that this one will call for an addition of the two equations. So we are going to say here, equation 1 plus equation 1 plus equation 1 plus equation 2. So we'll have to look at a plus 2b equals to 35,000. And then in the next part, we look at 3a minus 2b equals to 5,000. Can add. So this a plus 3a, you realize a plus 3a is the same as the 4a. Like I said before, positive 2a, positive 2b plus negative 2b, this one here will have to disappear. That is from integer. Meaning that if I have, now this is 35 plus 5,000, you end up getting 40,000. So this one means that we have eliminated a, we have eliminated b, and we are now going to find value of a. So we can go ahead, we divide by 4. Also go ahead here, divide by 4. So our a will be given to 10,000. That is our a. Meaning that by getting a, we have already eliminated b. I am going to use the same a to find the value of b. Like for example, if I come to and say into equation 1, that's not by substitution. Our equation 1 was a plus 2b equals to 35,000 shilling. But we already have the value of a, which means I am going to substitute the same a we have got here, which is 10,000, into equation 1. Thousand that. So after we collect like term, collecting like term means that we make what we want to get the subject. That is by making 2b subject. I will have the 2b the subject. Still, when collecting like term, we consider the integer, the sign given to what you are supposed to collect with the where you are supposed to take it. Like here, it is a positive, meaning that whenever it is going to go the other side, it is supposed to be negative. That is why I will have the 50, the 35,000 minus 10 minus 10,000. So you'll have your 2b is 35 minus 10. That will end up giving us 25,000. So we can have the value of b, that is by 2, by 2. Our b, you realize that if I divide 25,000 by 2, we will get the answer, which is around 12,500, 12,500 shillings. Go back to our part. That was part 1. Part 1, they were saying that we should do L of research equals determine the daily cost of maintaining one solar system and one biogas system. Go back to our statement where we gave our A to be the solar system and we gave our B to be the biogas system. And when you look at what we have obtained here, you realize that A. We have obtained it as 10,000, which should be the cost of one solar system. And our B, we have obtained it as 12,500, which should be the cost of one biogas system. Meaning that to finish up part A or to finish up part 1, we are going to make a conclusion. The conclusion be basing on the statement. Meaning, we are going to say, therefore, the cost of one solar system is shilling 10,000, and the cost of one biogas system is shilling 12. Like for example, if I come up with to try to say in my equation 1 that if I add the A plus the 2 of B, will I be able to get that 5? Or in the equation 2, that if I have the series of A, then I subtract the 2 of B, will I be able to get the 5? The 5,000. So you have to go back sometimes and then you test on your statement by proving that the equation you have used is the correct equation. So on part 2, they are telling us to represent Mr. Gozzi's produces as the inequalities and the equation. Last time we said that when you talk about the inequalities, here means we are going to look at the linear programming, whereby in the linear programming or the inequalities, the sign we always use. So meaning that in the part where we have stopped from part 1, we look at part 2 from where the part 1 ended. They're saying he finds it difficult to determine the daily cost, the daily maintenance cost for each system. The paper he produces are of 2 categories. So we are given the 2 categories of the papers, that is paper X and paper Y. So we look at part 2. Part 2, we are dealing with the paper. Part 2, we are dealing with paper X and paper Y. They're telling us here that he realized that he can produce at least 20 papers of X. When you talk about the word at least means someone is either that one there or more than that one there. Meaning that we are supposed to use the inequalities of greater than or equals to. Paper X being either equals to 20 or greater than 20. So in our first part, that is the inequalities now we are forming. We're going to have paper X being greater than or equals to 20. That is for the statement saying at least 20 papers for X. And then in the next statement, they are saying the numbers of paper X should not be less than twice the quantity of paper Y. Should not be less than means that it is either equal to that or greater than that one there, meaning that the same thing will also mean at least. So they are saying the number of paper X produced should not be less than. So it is either greater than or equals to 2 times the paper y. That is our second statement. Then in the next statement, they are saying, given that the cost of for paper X is the and the paper Y is shilling 200 and 300 respectively. He wants to ensure that the total cost does not exceed 554,000. So we can look at the constraint. The constraint for the cost. The constraint for the cost, they are saying that the cost for X and the cost for Y is 200 and 300 respectively. But the total cost should not exceed 54,000. Meaning that if I come and get the 200 for X, and then we add it with the 300 for Y, does not exceed means it is either equals to 54,000 or less than 54,000. Meaning that the total cost for these two can either be less than, that is the meaning of does not exceed, or equals to 54,000. You realize that is now becomes our inequality equation 3. So also here they are saying he needs to know the quantity of paper X and paper Y he can produce to maximize the profit, given that the unit profit realized from paper X and paper Y are 500 and 600 respectively. You realize that on that profit there, they have not given us the total profit, meaning that this one here will not act as an equation, or it will not act as the inequality. But here we are going to look at the expression for the profit. So I will come and say here, I will come and say let P represent the profit. If our P represents the profit, meaning the profit we are going to look at the profit in the two items, that is the paper X and the paper and 600 of paper Y. Sometimes this X here to come up with the maximum profit and the numbers of paper X and the paper Y. I am the inequality graph. But before we of y. So if I have this one here as the xy, because this is what we are supposed to go and use in the graph, you realize that they have told us that our x is the same as the 20. But now, at this point, we don't have value y. The y is 0 because y cannot be seen here. So our coordinates, we are going to start from part 2. We are going to set for x equals to 2, for x equals to 2y. For x equals to 2y, you realize that we are having two unknowns in one equation. That is x and y, meaning that I have to go and get the two coordinates also for this same statement. Getting coordinates, we'll have our table drawn. Have our table drawn here. And then on this table, said before that on this table we can choose any value of the unknown of our choice. Like if I want to start from x, I can say when my x is 0, this is any value I have chosen. Someone can go and use 1. Someone can go and choose 2. Any of your choice. So now, if my x is equal to 0, you realize that if I come in my expression here, when x is equal to 2y, because already we have said our x is 0, I am going to come and put where there's x, I put a 0, so that we'll be able to get the value of y. You discover that if I get the value of y by dividing both sides by 2, even at this point, our y will be equals to 0. So that is the also 0. And then, if you come and look at the second value, the second coordinate, for second coordinate, I am going to use another value. I may not use 0. I may say for my x, let me say for my y equals to negative 2. I've obtained my value of y 2. Meaning that if I come to my expression here, this time around we are going to look for the value of x. So we are going to say when x, our y, we say that it's the same as 2. So you multiply this one by negative 2. Our x will be negative 4. Then I also put it here as negative 4. So which means that after now putting them like this, we are going to obtain the coordinates of what we have got. The first coordinate, we say that 0. And then the second part, we said our x is negative 4 and y is negative 2. Meaning that for the case of now, these 2 points will be used for plotting the equation x equals to 2y. So that is the done. We come to the second one. That was the 200x plus 300y equals to 54,000. 2, we can say for 200x plus 300y equals to 54,000. Sometimes this equation becomes very big in such a way that using them is the also add, but we can get the same answer. So what we can look at here, someone can say I first reduce these equations so that it looks in a simplest form. Like if I look at this one now, if I try to reduce, you realize that all the numbers you're seeing here is carrying at least 2 zeros. So if it is carrying at least 2 zeros, meaning that I can divide each of this one here also by 100, because 100 it is the only thing that carries two zeros. So if I come and say reducing by 100, so you have the 200 of x we reduce by 100 plus 300 of y reduced by 100 equals to 54,000 also reduced by 100. So this will act as 2x, because the two zeros have cancelled. Then this one will act as 3y, because also the two zeros have cancelled. Meaning that here we'll have the 554, the 540. So the 540 is now what we are going to use in combine the 2x plus 3y. Then we also come up with our points we are supposed to use for plotting. No. So you can have this one here as the x, then we have this one here as the y, also at the same time. If we have those, we also have our values. Our values, this time around, I am going to choose any other values apart from 0. I can say for my x, being, let me say, if I make my x to be 20 here. If my x is a 20, what will be by 3, we're getting 166.66 recurring. So this one I can make it 1 dp. That's 167. That is it there. So that is for the value of x, for the value of y. Then for the value of y, when I'm obtaining for x, we can also use any value. Let me say here I have used 40, which will also act as my assumed value. So if I use 40 as my assumed value, meaning that we are also going to come and substitute here in the equation we are seeing here. That is the 540. If I substitute for y equals to 40 half 3 of 40 equals to 540. So meaning this is the 120 equals our coordinates will have x, y being equals to, this is 2, 20, 167, Then another one is 2, 10, and 210 and 40. So these are the coordinates we are supposed to go and plot on our. These are the coordinates for -2. The second line we are having 20, 167, and 210, 40. Then the third line we are having 20, 0. Then we have others like x equals 0 and y equals to 0. Last time we said x equals 0 and y equals to 0 is the same as the line at x-axis and y-axis respectively. So we can look at how our graph will appear. This is point. That is our graph. We are going to see which scale can we use, because when you look at the values we have obtained here, these values are having their sum are smaller than the values for the second line, meaning that I will also look at the scale I can use so that we can be able to plot the first coordinate. So if I look at the scale, like someone can say we use a scale of 1 centimeter, possibly on x. If I use a scale of 1 centimeter, possibly on x, I can first look at the x value we are having. But when you look at the x value we are having, you realize that in the second line we are having the x value which is the 200, 210. So you realize that 210 may give us, we may obtain a scale where it may be hard for us to plot to plot the first line. So meaning I am going to make an adjustment on this one here by at least increasing what we are using on the second, on this line x equals to y. I am going to change this so that it can match with that. I am going to say if I use this one here, maybe if I use my y maybe to be 50 here. If I use my y to be 50, you realize if I come and substitute here that x equals to 2y, since our y is 50, our x is going to be 100. So you can have the x y be equals to, the first one is 0, 0. Then the second one will now be 150. So you realize that in the second point we have obtained, they are now somehow matching with at least the points for the second line and also with the point for the first line respectively. Meaning that here we can now come and easily choose the scale we are to use. If I come and say we use a scale, let us first write here. If I come and say at the x-axis, I use a scale of 2 centimeters to represent 50 units. Then on the y-axis, I'm going to use a scale of, depending on our values here. Depending on our values here, we are having bigger coordinates on x, on y, being 167. Meaning that still I can use a scale of 2 centimeters. Here, I can use a scale of 2 centimeters, maybe to make 20 to make still the 50 units. So we'll have the 2 centimeters. 2 centimeters is equivalent to 10 small boxes. That is from the starting point of each axis. Meaning that if I'm here, I'm going to count 10 small boxes to represent the 50 units. I count another 10 to make 100. I count another 10 to make 150. I count another 10 to make 200. Then I count another 10 to make 150. If I try to look at what each of these one here will represent, or what will be each small box, which means I will, for one box, we are going to say for one box, we get the numbers, the distance or the scale we have, and then we divide by the numbers of small boxes between the axis and then the scale, which is equals to 10 small boxes. Meaning that if you look at on here, each small box will be making 5 units. That is on X. So even here, you can say negative 50. On X, each small box is making 5 units. What about on Y? On Y, since we have said that even 2 centimeters is for 50 units, this one will also remain the same. Each small box will still make 5 units. So we'll have the 50, have the 100, have the 150, have the 200. Since our bigger value, since our bigger value on that axis is 200. So I'm going to start by plotting the first point. Last time we said that for this line, x equals 0 and y equals 0, that one should be our starting point. You must go and shade before you plot the other line. So my shading is done. That is for the line x equals 0 and y equals to 0. My second point is coming from the line x equals to 20. X equals to 20, meaning our line should pass from where there is x, where there is 20 on x axis. But before we add this equation, being given as the x greater than or equals to 20. That was the basing on the inequalities. X being greater than or equals to 20, we said greater than or equals to sign. This one calls for a solid line for this case. Meaning, we'll come there, we look for x equals to 20, and when you realize that your x equals to 20 will be between 0 and 50. But we said each small box is the 5. Meaning that if I go ahead and then I count 5 small boxes, 5 small boxes will be equivalent to 20. So I'm going to have, assuming my 20 is here, so this is it. This one will act as the line x equals to 20. I'm assuming this is my 4 small boxes. We also come the second line, that is x equals to 2y. Even our x equals to 2y. In the inequality, it was x greater than or equals to 2y. Meaning, this one will also call for a solid line still. So we come to this, our point, which was 0, 0. You know 0, 0, it is always the origin of all the axes. Then we look at 100 for x and 50 for y. 100 for x on the x-axis and 50 for y on the y-axis. If you look at this, you realize that this is the point we are going to call 150 for y. if I get the 40, we are looking for divide by 5. The answer we are going to get is 8. 8 will now become the number of small boxes we are supposed to look at to obtain these coordinates. So I am going to assume my 8 is here. If my 8 is there, meaning it's 210, my first point here. Then my second point is 20 and 167. Already I have 20 here, which is this line, meaning I am supposed to go and get 167. 167 is between 150 and 200. So before that, I will have to first look at 160 before I look at the 7. 160 is going to be, if I get the one, already I have 150, meaning 167 minus that, you'll have only 17 remaining. Because if I add the 50, 150 plus this, get 167. If I divide that 17 by 5, you realize that you're going to get 3 point something. Meaning, after 150, we are supposed to count 3 small boxes. The 3 small boxes will represent 165. Then I will now estimate 167, whereby I can say somewhere here. Then we also join this line. This line, for the case of this was less than or equals to. Being less than or equals to means even the line we are going to draw here should be a solid line. So this will also be drawn as this, passing through the point that. So meaning this is the same as 200x plus 300y equals to 540. 540,000. It was 54. 540 was 54. Now we are going to come and check, or which will represent the region that does not satisfy the inequality. So for the region that does not satisfy the inequality, so far we have shaded the two. That is the obtained inequalities of x greater than or equals 0 and y greater than or equals to 0. Let us look at how these 3 remaining lines will be shaded. I will start with the first line, that was x greater than or equals to 20. So x greater than or equals to 20. We say that we get any point that is not lying on this line. If this is our line, this, we are going to get any point that is not on this line here, of which that point can either be this side of the line, that is on the right hand side, or can be this side of the line, that is on the left hand side. Because now when you look at this, you realize that we are having the variety of points picked. Someone can even pick a point from here, or another one can pick a point from the end here, so long as it is not on this line. So I am going to take any point. I can even take a point which is 50 and 0, because this 50, 0 is not lying on this line for x equals to 20. So 50, 0 is showing us that we have our x as 50 and our y as 0. But unfortunately, when you look at in the equation, we don't have y, we only have x. Meaning, I will have nowhere to substitute the 0, but I have where to substitute the 50. So I am going to say where there's x, I'm going to put 50 greater than or equals to 20. So now, if they are to ask you a question that is 50 greater than or equals to 20, this answer is a yes, meaning that this is a true value. So being a true value, remind us that where we have taken our point, it is a true side we are looking for. Meaning the side remaining, it is the side which is wanted. So this one will give us the side on the left to be the unwanted side. That is for the first line, x greater than or equals to 20. Then we are coming for the second line. That was x greater than or equals to 2y. The line is represented by x equals to 2y. That is what is representing the line. Still, I am going to come in my line, which is this one here. I'll take any point that is not lying in that line. For an example, I can take a point which is up, or I can take a point which is down. If I want to take a point which is up, this time I can say I am going to assume that we are having 100 and 100, which is here. So 100 and 100, they are not lying in this line, but they are lying above the what? They are lying above the line. That is the point. So that is the point 100, 100. See, 100 for x and 100 for y. So we are going to have the 100 for x greater than or equal to 2 of 100 for y, which will be 100 greater than or equals to 200. Then another question will come. Is 100 greater than or equals to 200? It is a very big no, because this 100 is smaller than the 200, meaning that this is not true. This is a false. Meaning, if it is not true, the side we have taken, it is not a true side, and the remaining side becomes a true side. So this one here will require us now to shade side where the point was taken from. That is for the second line. And then for the third one, we are talking about 200x plus 300y being equals to 54,000. Before, it was written as 200x plus 300y being less than or equals to. When you go back to your inequality, this is what we use for that line, being less than or equals to 54,000. This one here becomes our line. So since it is our line, I am also going to take any point that is not lying on that line. Example, I can say I am going to take a point 150, maybe and 25. 25 is lying between 0 and 50. So if I take 150 for x and 25 for y, come and substitute. Have the 2 of the x, which is 150, plus the 300 of y, which is 25. This one should be less than or equals to 54. Less than or equals to 54,000. So I'm going to compute for this side. That is having 200 into 150 plus 300 into 25. Cross the bracket. So this is the 37,500, which is less than or equals to 54. Less than or equals to 54,000. So another question comes. Is 37,500 less than or equals to 54,000? Automatically, this is a true. The 37 is less than the 54. Meaning, the side we have taken or the side of our point becomes the true side. That is now this 3 points to be the maximum. I am going to take for only 3 points, which is lying in this region, which is unshaded. Like in the first part, if I take any point, let me say any point here, I can say 10. I'm going to substitute here the maximum. That is the first value of the profit, which will be 500 of 100 for x plus 600 of 25 for y. So let us see what will act as our P1. That is the first profit. This 100 plus 600 of 25. So this is 65,000. That is for the first one. Then for the second one, I will also still take the point, because this time if I say, let me take a point 150 and 50, which will still also be in the unshaded part. Then I substitute 150 being x and 50 being y. We are getting the second value of the profit. P2, that is the 500 of x plus 600 of y. That is 50. Our P2 will be 500 of 150 plus 600 of 50. We also have, this is the 105,000. Then I also can come and take another point, and taking still the point in the unshaded part, can say 240, because 40 is here. 240. So this one will give us the third value of the profit. That will be 500 of 200 plus 600 of 40. Can also compute. So this is our P3 giving me 124,000. So basing on the three values of the profit we have obtained, that is by taking the points the unshaded region, you realize that the profit we are going to obtain here should be the profit that is maximum. Maximum means the bigger amount we are seeing. The maximum profit, if I compare the profit 1, that was 65,000. Profit 2 is the 105,000. And then profit 3 is 124,000. You realize that profit 3 is the maximum. And it being a maximum, meaning on the paper X, we are supposed to produce the number of 200. And then on paper Y, we are supposed to produce number of 40. So let us see how I'm going to proceed. We are going to say, we should produce, 200 of paper X and 40 of paper Y to maximize a profit of shilling, maximize a profit of shilling 124, maximize a profit of shilling 124,000. So that becomes the end of our scenario. That was Kamsa item 2. That was set in that paper.
So, like I said before, that for any recurrent concerning what we have discussed, you always go to the inbox, then you inbox me for any scenario
you want. I am going to give you my number here, where you can use inbox me either on WhatsApp. You can use the number at 0783602 702. The moment you inbox me, I will automatically send for you the item. Thank you for attending, and can be preparing for the next item.